Good afternoon, dear participants from Asia countries, and good morning or good evening, ladies and gentlemen from other continent countries. I am Pinjing He from Tongji University, China. I'm very happy to meet you in this international webinar on valorization of waste incineration residues in construction via Zoom, and wish we are able to meet and exchange ideas face-to-face in near future. In the following 30 minutes, I'm going to introduce and discuss with you the practice and challenges for beneficial use of municipal solid waste incineration bottom ash in China. My presentation has 5 aspects: the fast-growing municipal solid waste incineration in China, the corresponding generation of bottom ash, the related regulations and standards for bottom ash management, the mainstream pretreatment and the utilization process of bottom ash, as well as the challenges we face so far. Now, I will give you a brief introduction on the current situation of municipal solid waste incineration in China, the evolution of treatment capacity, and the uneven distribution in different Chinese provinces and cities. As shown in the upper left figure, China has made great efforts in improving solid waste management in the last 2 decades. With economic development, continuous urbanization, and populated growth, the collection and processing amount of municipal solid waste have been greatly increased. In the year 2020, 235 million tons of municipal solid waste from 660 Chinese cities were collected, among which more than 99.8% were thermochemically or biologically treated or disposed of in sanitary landfill, while in the year 2002, the value was only 54%. To deal with the huge amount of solid waste, incineration with heat recovery has become the priority choice in China because of the significant volume and mass reduction, hygienic risk reduction, land saving, energy recovery, and it can be located closely to the source compared with landfilling. Therefore, a rapid increase for incineration can be observed. In comparison, the incineration ratio in European countries, Japan, and the United States have been relatively stable in recent years, ranging from 12% in USA to 80% in Japan. Incineration has become the mainstream technology for municipal solid waste management in Chinese cities. The treatment ratio by incineration increased from 2% in 2002 to 62% in 2020. The number of incineration plants reached to more than 460. In addition, the average treatment capacity of the incinerators is increasing too, around 1,030 tons per day in 2020, indicating that small-scale incinerators have been shut down and more large-scale incinerators have been put into operation in view of treatment efficiency or secondary pollution control. All of the incinerators are equipped with heat recovery system and steam generators. The increasing trend of incineration was also found in counties, where the incinerated waste reached to 17 million tons in 2020, accounting for 25% of the collected domestic waste. In September 2020, the revised law of China on prevention and control of environmental pollution by solid wastes came into force, which addressed nationwide waste classification, source separation. This encourages the continuous construction of new incinerators, as well as the booming development of biological treatment facilities for source-collected food waste. Furthermore, the zero landfilling of raw refuse promoted in many cities results in the significant decrease of landfilling ratio According to the development plan of municipal solid waste classification and treatment facilities in the 14th five-year plan, the incineration capacity will further increase and exceed 65% of the total capacity by the end of 2025 for the whole country. Due to the great variance in population density, economic development level, climate differences, customer, etc. in China, significant difference of waste incineration in the different provinces was shown in the map. You can see in eastern areas, which are densely populated and more developed, in majority of municipal solid waste is incinerated. The quantity of the waste incinerated in the three provinces, Jiangsu, Zhejiang, and Guangdong provinces, accounted for 1/3 of the total incinerated waste in the country. As a result, more bottom ash is produced in these three provinces. Since so many municipal solid waste is incinerated, then how many bottom ash is generated? And what are about their characteristics? The generation of bottom ash is significantly influenced by the types of incinerators. There are mainly two types of incinerators adopted for municipal solid waste incineration in China. That is great furnace and fluidized bed. It was reported that the yield of bottom ash from great furnace is around 15 to 25% in the cities, while that from fluidized bed incinerators is only 5 to 10% on mass basis of the incinerated waste. This diagram shows the numbers of incineration lines in various provinces or regions till January 2021. It can be found that the number of great furnace accounts for more than 86%, and the number of fluidized bed incinerators continue to decrease because of exceeding permitted levels of carbon monoxide emission, more frequent maintenance requirement, as well as more generation of air pollution control residues, which are classified as hazardous waste in China. So we can estimate the generation of bottom ash according to its yield from great furnace and the amount of waste incinerated. Here, the diagram shows the typical great furnace incinerator in China. After combustion, the residues is cooled down by water quenching and then moved to the ash bank by slag machine. As an example, the similar process is adopted in the 9 incineration plants in Shanghai to quench bottom ash. So their yields of bottom ash can be referred, as shown in the left figure. The yield of bottom ash varies from 15 to 28% during those years of operation. Besides the influence of the furnace type and combustion efficiency, the yield of bottom ash is also greatly dependent on the characteristics of municipal solid waste, which change city by city, as can be seen in the ternary diagram of waste composition, food waste, other organic and inorganic. So an average value of 20% is used to estimate the generation of bottom ash from municipal solid waste incineration in Chinese cities, which is about 29 million tons in the year 2020. Similarly, the contents and leached concentrations of pollutants from bottom ash vary with incinerators, locations, seasons, and so on, due to the differences of incinerated waste and incineration conditions. But in general, the leaching concentrations of heavy metals from bottom ash, the contents of soluble salts and dioxins are relatively low. So bottom ashes from municipal solid waste incinerators are usually classified as non-hazardous waste in most countries, including in China. The values listed in this slide show the leaching toxicity, the contents of heavy metals, soluble salts, and dioxins in bottom ash produced from incinerators in China, which have no significant differences from those in other countries. As we know, bottom ash is composed of the inorganics from municipal solid waste such as melting slag, ceramic and brick debris, metals, glasses, and so on, as well as the unburned paper, plastics, and textile components. According to the standard for pollution control under municipal solid waste incineration, the loss of ignition for bottom ash should be no more than 5%. And in some cities, such as in Shanghai, the limit value is 3%. This table shows the particle size distribution of bottom ash, together with the density and the main chemical components in the bottom ash with different sizes, which are similar to natural aggregates. Therefore, bottom ash has great application prospects for valorization in construction. To well manage the beneficial use of bottom ash and prevent the secondary pollution during the valorization, a series of regulations and standards have been issued in China. The highest level is the revised law on prevention and control of environmental pollution caused by solid waste, in which reduction and comprehensive utilization are highlighted. In the year 2020, the technical guideline on pollution prevention and control for solid waste recycling is issued, which underlines the importance of environmental safety and human health during waste recycling. It is recommended to identify the environmental pollution factors and take corresponding measurement to prevent the pollution. For the valorization in construction, if the waste is recycled in the cement manufacturing, the manufacturing process as well as the cement product should comply with the standards for co-processing of solid waste in cement kiln. Meanwhile, if the waste is recycled to produce aggregate, road-based materials, bricks, glass, ceramic products, the manufacturing process should comply with related industry standards, and the pollution control for the product can refer to the standard of cement from co-processing solid waste. This table summarizes the limit values of heavy metal contents in the feedstock and the cement product, as well as the leaching toxicity of the cement containing recycled waste. However, the limit values are recommended guidance, and this guideline is not a compulsory standard. In addition, the other products such as aggregate, bricks, road-based materials, etc. have no specific standards, so they are recommended to refer the standards for cement from co-processing of solid waste. For bottom ash aggregate, a specific standard was issued in the year 2010, in which the limits of radionuclide, loss of ignition, leaching toxicity of heavy metals were proposed. Besides the technical specifications for the coarse and fine aggregate from bottom ash, such as the size grading, contents of metals, light substances, moisture, and comprehensive strength, the leaching toxicity is referring to the identification standards for hazardous waste, which is less stringent compared with recommended values for cement as listed in the last slide. In conclusion, the specific and the compulsory pollution control standards with regard to the various utilization scenarios of the bottom ash derived products are lacking nationwide. As far as I know, there is a group standard for bottom ash utilization under preparation, which is proposed last year. For example, in Shanghai city, a local standard was issued in the year 2017, which addresses the technical specification or application of bottom ash aggregate for road engineering. The different usages, including subgrade backfilling, improvement layer, subbase layer, and the base layer, are considered. Besides moisture content, bulk density, and crushing value, the soluble salt of chloride and sulfate, leachate pH, and conductivity are also regulated. Another example, in Taiwan, 3 regulations or guidelines were published to encourage the bottom ash recycling, as well as the valorization of bottom ash aggregate in road grading and the backfilling materials. The leaching toxicity, water-soluble chloride, the dioxin content in the different types of product are regulated. The regulations for bottom ash valorization in construction in European countries can be good references for us. In Denmark, for example, the total contents and leaching concentrations of heavy metals, as well as leached chloride and sulfate, are defined for the application of residues in construction engineering, together with the restriction of the locations for the placement of bottom ash products. Here, Netherlands and Germany also have their standards to stipulate the technical specification and environmental pollution prevention for bottom ash products as building material. This table summarized the limit values of leached heavy metals for the various utilization of bottom ash in road engineering and civil engineering in some European countries, which shows a variance. Japan also supports and encourages the use of municipal solid waste incineration residues to prepare concrete aggregates and subgrade materials. Similarly, the contents and leaching concentrations of contaminants are restricted to prevent pollution. Then, for China, more works need to be done for improving the standard system in order to well manage bottom ash valorization in an environmental friendly and economical way in the future. It has already been addressed by the government that development and improvement of standard system is one of the important work in the 14th five-year plan. Guided by the limited regulations and standards, beneficial use of bottom ash as construction materials have already been applied in different municipal solid waste incinerators in China, and the pretreatment processes have been developed to recover valuable metals and remove unburned substances. According to a survey carried out by Ministry of Housing and Urban Rural Development of China during the year 2017 to 2018, around 82% of bottom ash was recycled. 15% of bottom ash was landfilled, and 3% was co-processed in cement kiln. Most of the recycled bottom ash is used to produce baking-free bricks or aggregate for road engineering. Before utilization, pretreatment is necessary to adjust the size distribution, remove unburned organic matter, and recover ferrous and non-ferrous metals. There are mainly 2 kinds of pretreatment processes for bottom ash, wet and dry methods. Because bottom ash is usually water quenched and removed from incinerators, wet pretreatment has been widely used in China. This schematic diagram shows a typical wet process. The unburned substances are fed back into incinerators. By wet crushing, magnetic jigging, and shaking separation, ferrous and non-ferrous metals can be recovered, and aggregate, usually with size less than 10 millimeter, is obtained. The aggregate product is of poor size grading, so it is mainly used in building materials such as bricks and cement blocks. About 30% of the bottom ash will end up in the sludge, which enriched in heavy metals and is then usually landfilled or just dumping. Furthermore, its recovery efficiency for aluminum is not good, and water consumption is high, around 0.5 ton of water for 1 ton of bottom ash considering water recycling. However, the wet process has a good separation efficiency for copper compared with dry method, which has a higher value, so it is more profitable. As a result, become the main technology, the bottom ash pretreatment in China. In a few incinerators, the dry pretreatment method is adopted, which includes screening and size reduction, air separation, magnetic and eddy current separation. The aggregates are well graded, so they can be used as road aggregates or other substitute aggregate in construction products. Two-stage eddy current separation is usually adopted, for which the recovery efficiency of non-ferrous metals from the bottom ash with size less than 5 millimeter is not satisfied. Now, let's talk about some challenges we confronted during the bottom ash valorization. The first challenge, according to our study, the bottom ash in China contains relatively low and also influences the quality of the bottom ash material. The metal and the non-ferrous metals need to be refined before utilization, as they are partially oxidized during incineration. Later, on the cost and benefit analysis, environmental impact assessment based on field applications of bottom ash in China. It is usually the private construction material manufacturers, small scale, instead of incineration plants, who are responsible for the pretreatment and utilization. They usually don't like to share the operation data, and the long-term environmental impacts are not well concerned. The insufficient data inhibit the proper improvement of technologies as well as corresponding standards. After visiting several pretreatment projects, it is found that the working environmental need to be improved, such as wastewater leakage control. The landfilling of dewatered sludge not only reduces the utilization ratio of bottom ash, but also occupies the valuable landfill space. Valorization method to recycle this part, dewatered sludge, is necessary. For the utilization of bottom ash products, it is lacking of specialized pollution control standards for the process, as well as for the product considering different application scenarios, as mentioned before. By now, we still have no standards and guidelines on environmental impacts and risk assessment for beneficial utilization of bottom ash. Is it safe for utilization in the long term? Further lab and field studies need to be carried out. For example, our lab investigated the ecotoxicity and phytotoxicity of bottom ash leachate and found some relationship between heavy metals as well as TOC leaching with the toxicity value, indicating that the sustainability of existing technologies for bottom ash treatment, utilization, and disposal needs further long-term assessment. There is an urgent need to improve our standard system for better management of bottom ash utilization. Anyway, we know more works are needed to be done in the future. That's my point of view. Thank you for your attention.